Geometry students, lots of information today, but not too difficult, so I think it should go just fine. First, let's talk about some properties of proportions that I think are pretty obvious, but still interesting to look at. So here, if A over B is equal to C over D, then you can take the reciprocal. This one I use a lot. It's pretty helpful. You can interchange the numerator with the denominator here, and that's not one that I've used a lot, but it makes sense algebraically to me. Especially if you were to multiply this by BD, you would get AD equals CB, and then you could divide both sides by DC, and you would produce from here, well, not DC, but you could divide by C and divide by D. Yeah, divide by CD. And then the C's would cancel here, the D's would cancel here. I've never really used this property, but it's there. I don't use these names of means and extremes, but it's just something to look at. And then the other one is in a proportion if you add the value of the denominator. I've never done that either, but basically what it's saying is if you take A over B and add B over B, you're adding 1. And if you take C over D and you add D over D, you're adding 1. So all you did to this equation was add 1 to both sides creatively, and yeah, of course that works. This is the property I'm really worried about. This is the one that I use a lot, flipping a proportion. So anyway, some other things about proportions to look at. You've seen this before, especially in architecture. So this idea of a scale drawing, that's what all those blueprints for the tiny house are. And the scale is that ratio that describes the two dimensions. So just, that, but it's just something worth pointing out. You're going to be working with problems like this where MN is to RS what NP is to ST. So if you write that out, you get 8 is to 10 what 4 is to x. And most people can then say, oh, double this, you get this, x equals 5. Or sorry, double this to get that. Another way to do it algebraically is to come over here and say, okay, 10 over 8 then equals x over 4. Reduce and say 5 over 4 equals x over 4. Therefore, x has to equal 5. That's one way to do it. You can multiply both sides of the proportion here by 4, and then you would get 10 over 8 times 4, which would be 40 over 8, which is 5. So lots of ways to get 5. Make sure you show your work. I won't always make it so nice. That's just a simple example. Big idea, similar polygons. We say two polygons are similar if their corresponding angles are congruent. So that's important right there. The corresponding angles are the same, and the corresponding side lengths are proportional. So remember when we talked about congruent triangles and why there was no AAA. That's because angles being congruent do not mean the triangles are similar. Congruent, it does mean that they're similar. So the way we write a polygon name is A, B, C, D, or you just pick a letter and you go around in one direction. Another way to do this would be A, D, C, B. That would be an appropriate name for it. But just like with triangle congruence, our similar symbol is just the tilde, and then the letter order matters. So if I say A, D, C, B, then I better say E, H, G, F, because angle B is the same as angle F. But this is what's really important, that the ratios of the corresponding sides are all equal. So let's look at a practice problem. If we were to try to find the scale factor here, and the scale factor is just that ratio, we can see F and Z, J and W, H and X, G and Y. So we know it's FJHG is similar to ZWXY. So that means I'm just going to go around starting with 16 and 20, and I'm going to go around clockwise. So we should have 16 over 20 equals 12 over 15, which equals 24 over 30, which equals 20 over 25. And if we reduce all of these fractions, factor of 4, 4 to 5. Factor of 3, 4 to 5. Factor of 6, 4 to 5. And lastly, factor of 5, 4 to 5. Then we can see the ratio, the scale factor here would be 4 to 5. Good? That ratio, if we didn't know this value, we could say, oh, 16 is to 20 what 24 is to x. Or a lot of times I like to set it up with what I'm trying to solve for. And I say x is to 24 what 20 is to 16. Or x is to 24 what we're taking from this side, 5 is to 4. Multiply both sides by 24 and you get x equals 30, which is what we knew that side already was. Good? Other things to know in this chapter, if you have similar polygons, then their perimeters are similar in that same ratio. And that one should seem pretty obvious if all the sides are in the same ratio. Adding up all the sides should be in the same ratio. Here's a really interesting one down here, corresponding lengths. This means all the corresponding lengths. So we could talk about medians, we could talk about altitudes, we could talk about all sorts of segments that a triangle or a polygon might have, and those corresponding segments would also be in the same ratio. Lastly, if the scale factor is 1 to 1, we can say that they're similar, but we can also say that they're congruent. And I'm going to ask that you write this, because we know we know a triangle is similar to itself if they're the. I just like congruent. Let's just go with congruence, because it kind of is weird to talk about them being similar if the scale factor is 1. So believe it or not, all that information is wrapped up in 2 different sections in our geometry book. So on class Tuesday, you're going to have to work through 2 sections. I'll take that into account when I assign the problems, but we're trying to speed up as we go through till the end of this year. Remember, only 24 classes left. Hope you're good. Peace.